How are you? And feel at home. And welcome to this particular session of paper 3. Today, I just wanted us to tackle a particular question that involves charging and also discharging a capacitor. So the question provided says that you are provided with the following, that is, two new dry cells, that is size D, and then we also have a cell holder, a switch, a milliammeter of range 0 to 1, a capacitor that is labeled C, 8 connecting wires, and of course at least 4 with crocodile clips at one end, a stopwatch, and also a carbon resistor that is labeled R. Now you're supposed to proceed as follows. That means your switch or your diagram should be connected as the indicated diagram. So I've tried first of all to provide or to discuss what you are given. Here I have what we refer to this case as a milliammeter that you can see. This is a milliammeter of range 0 to 1. That is a DC milliammeter. Then on the other side, I have what we refer to this case as a carbon resistor that is labeled R. And then at this particular point, I have a capacitor. That capacitor is labeled C. Then I also have a stopwatch. That stopwatch is actually going to be used when you are timing for the time taken to discharge after charging that particular capacitor. Then I have what we refer to this case as a switch. A switch is actually provided for the purpose of disconnecting the flow of current. And then I have a cell holder together with the cells that are inserted already. Then I have what we call the wires with the crocodile clips. Those are for clipping up and so on. So for me to connect this as required, I'm going to start from one side of the cell that I'm starting from here, where this crocodile clip is. Then I'll take it to the switch. And remember the switch is already open. The switch is open, so we are going to close it once we are through with the connection. And then from the switch, I'm tapping that one back to the capacitor, and you can see from the capacitor I'm taking it to the carbon resistor. You see, one is coming from that one to the carbon resistor, and then from the carbon resistor, as you can actually see, I'm taking this one back to the milliammeter. Then from the milliammeter, I'm taking it back to the dry cells, and from the dry cells, I'm taking another cable that is going to complete the circuit with this particular carbon. One wire is coming to the complete the circuit under the capacitor. Now, once I've connected this, remember this part is the part they talked about when I close it, and I close this particular switch. This is the switch here. If I close this particular switch and then I observe what happens, now you can look at it as I close the switch, look at what happens. So the milliammeter is going to read around 0.6 milliampere. Now observe when I disconnect the switch. As I disconnect the switch, you can see the capacitor is discharging as slowly as the current reduces to 0. You see, the discharging is going on and the capacitor is losing those charges, and therefore the milliammeter is reading 0 current for that case. Now, if I close it again, it means again I'm charging that particular capacitor. So that is the process of charging and discharging that particular capacitor. And that is how the overview of that connection should look like. That when you connect and you realize that the milliammeter is deflecting in the opposite side, then it tells you that maybe possibly you interchanged the terminal of the battery, and that one can be easily rectified by shifting those terminals, and therefore that is going to be easily rectified in that manner. That's how you're supposed to connect. And once you've connected, then you have to go back to the questions. And the first question was saying that name the process which takes place when the switch S is closed. And the simple thing that tells you that that is the process of charging the capacitor C. The second question, they're saying close the switch and record the maximum uh, current. And from that milliammeter, you can actually see that the maximum current that you can observe from there is approximately 0.60. I'm writing it to two decimal places because the milliammeter is giving the values to two decimal place accuracy. Once you've done that, you can actually take your stopwatch. You can reset it, go to the mode. Once you are there, you reset it back to 0, stop it, then you reset it back to 0. Once you have reset it back to 0, once you've reset it back to 0, you can again time it for that particular timing, whereby what you do with this is you charge it fully, and once you've charged it fully, you time your stopwatch. That stopwatch, you time it, start and stop the stopwatch. Once you've timed it, you record that particular value in that particular table that is given. Now you realize that once I disconnect this, the first value they are saying is that you record the time taken for this particular current to reduce from 0.6 uh, to 0.5. That means I'm going to disconnect the switch and record the time. Once I've recorded that time, I go to the next one. Again, I fully charge it. And then I also time the time taken for that particular capacitor to discharge to 0.4. I repeat the process until the time taken to reduce that charge to 0.1. Once I have the table, then I'll proceed on to the next question, which says plot the graph of the current, that is milliamperes, against time in seconds. So what I'm going to do, I'm going to first of all have the axis, have the quantities with the correct SI units, that is time and SI units, and then the title of my graph. And then the scale I've tried to use here is 2 centimeters to represent 0.2 milliampere on the y-axis, and 2 centimeters to represent 5 seconds on the x-axis or the time axis. Once I've done, I can now locate those points, and with the smooth line, I'll join those lines, and I'm getting a graph similar to that you can observe from that particular diagram. Then from the question, they are saying, from the graph, find the value of W, that is the value of I when t is equals to 10. So what I'm doing is that I'll take the ruler with a straight line from 10 and read the value on the y-axis. And indeed, that value you can actually see is 0.20 milliampere. Very necessary to provide the SI unit of that particular quantity. Once I've done that, the second question says, given that A is equals to 10 W, determine the value of A. From this particular graph, or from this particular question, what you are required to do is only to substitute. Remember already you have the value of W, so what you are required is to bring this W here and expand it and get the value that is required. Remember, W is 0.20, and multiplying by 10, we are getting 2.0 milliampere as the correct answer. The last question says that you determine the voltage across R at t is equals to 10 seconds, given that R equals to 4.7 kilo ohms. I want you to recall that always at any particular point, voltage is equals to current multiplied by resistance. And for this case, the current that we got at t equals to 10 was 0.20, but I'm multiplying by 10 raised to negative 3 to change into the correct SI unit of current, which is amperes, multiplied by 4.7. We are multiplying by 4.7, which is the correct SI unit of uh, resistance, that is times 10 power 3, to change it into amps or ohms, that case. And if you multiply this, you are getting the voltage to be 0.94 V as the correct answer. I believe that short demonstration on how to charge and discharge a capacitor was necessary, and I believe you have understood on how to connect that particular value. Follow me for more interesting lesson on paper 3 of KCSE Physics Practical. Thank you, and may God bless you.